Okay, my friends, we are in for some fun today. Why gravity is not a force. Now, this is Derek Mueller from Veritasium. Fabulous guy, very intelligent, but he's stuck on the Bohr model. You can't get anywhere with the Bohr model. It does not work. Okay, so Derek is going to be talking about gravity. And again, I have nothing against Derek whatsoever. He's a fabulous researcher. But once you get into the Bohr model, you're done. Nothing you say is going to be correct. Now, here's what the Standard Model says. Standard Model explains how basic building blocks of matter interact, governed by four fundamental forces. And it says how fabulous this theory is working, and they have all these different particles, and they do all these different crazy little things. Well, it's a particle zoo because they don't understand the actual particles that exist. It says, however, the most familiar force of all in our everyday lives is gravity, and it is not part of the Standard Model, as fitting gravity comfortably into this framework has proved to be a difficult challenge because the framework doesn't work. It's just wrong. Now, these are not my words. This is CERN. CERN says the Standard Model is, oh, it's fabulous, but we can't tell why this happens. It's too complicated. Okay, so here we go back to Derek. Now, he's going to be saying why gravity is not a force. Well, nobody knows what gravity is right now except me. I'm not kidding you. Nobody understands gravity. Now, they only have equations and all kinds of little doodles to come out with some formula that says, well, gravity must be there. We know things hit the Earth, so let's just make a bunch of little doodles up to account for it. Well, they can't account for it because they don't know dipole flood theory. Until you can understand dipole flood theory, nothing, not a single thing will ever make sense. Now, I love the way Derek does his job here. He is very, very good. And he's very right on top of things. If the Bohr model was correct, I can't see any flaw in his thinking. But the Bohr model is just wrong. So you start from the wrong place, you can't get to the right place. Now listen to this.
Albert Einstein said the happiest thought of his life was imagining a man falling off the roof of a house. What made Einstein so happy about this wasn't schadenfreude. It was the realization that this man, while he was falling, wouldn't feel his own weight. He would be weightless. And anything he dropped on his way down, well, it would remain stationary relative to him, or moving in uniform motion. The whole situation would be just like if you were in deep space, not near any large masses, with your spaceship at rest or coasting along at constant velocity. Here, you would feel no weight. Objects would remain stationary relative to you, or if you give them a push, they would move in a straight line at constant velocity. And you would be the very definition of an inertial observer. You're not accelerating, not in a gravitational field. All the laws of physics apply in your reference frame, meaning there is no experiment you could do to distinguish your inertial reference frame from any other. Now here comes the big leap. Einstein looks at these two scenarios and says they are equivalent. Not just similar, physically they are exactly the same thing. Which means man falling from roof is not in a gravitational field. There are no gravitational fields. And he is not accelerating. He is an inertial observer just like Rocketman. I know that these two situations look very different, but Einstein's equivalence principle tells us the one thing to focus on, the experience of the observer. If they feel weightless, then...
All right, I can tell you the one thing to focus on is that Einstein was literally wrong about virtually everything he said. Almost not a word he said was correct, and he's been held up as the biggest hero in science. Well, that's why we're so confused. Okay, so why was Einstein such a hero? He had 7 theories that changed the world. Well, I'm not disputing that, only he changed it for worse than better, in my opinion. Okay, so let's just cut right to the chase. Albert spent most of his life researching theories of relativity, investigating space, time, matter, and energy. So what were Albert's most significant theories? As we look back on this innovative thinker, here are some of Albert Einstein's most significant achievements. Quantum theory of light. So let's start with that. Okay, so this is Einstein's quantum theory of light, and they show a bunch of little pictures of things that they think might be the way light works. Well, let's look at what Einstein said. Einstein proposed his theory of light, stating that all light is composed of tiny packets of energy. I do not disagree. They are called photons. I do not disagree. He suggested these photons were particles. I do not disagree. But also had wave-like properties. I also do not disagree. A totally new idea at the time. Well, how could a particle also be a wave? Let me explain. Okay, I am going to prove to you exactly how a particle and a wave are the duality. The particle is right there. It's a magnetic particle. Its wave really surrounds it like this, is the zone of magnetism, all the way out to here, way out. This is being accelerated right now. And it's pushing its way through the air in front of it. That's why these particles are glowing, because these are pushing and these are shoving back, and everything glows when this is the main glow, because it's the pusher. These are the shovers, and they get the hell out of the way. Every one of these has a particle inside of it. I can't put these because they're going to knock the other ones off. It's just too much magnetism on the screen at the same time. Now, that's what's in every one of these waves. So it's boom, 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 boom. Now, can I show that? Yes, I absolutely can show that in extreme detail, and I can show these are magnetic particles. They have a black and a white attached to them. I'll show you that right now, and they can divide, and I will show you that. So Einstein, everything he said was wrong, literally everything. All right, I don't want to disparage Einstein too much, but the wave-particle duality is strictly a magnetic particle that is flying through the air, which is the photon. I will show you. It has a dark side and a white side, and it concusses with all the other white particles out here, and then these glow, they glow. The pusher glows much more than the shove back. They just get out of the way, and it goes through. But the reason you have a particle in a field is that's the particle, and it literally has a gigantic magnetic field surrounding it. And the field pushes like this is the field, way out here. The particle is this little tiny thing in the middle, just like two magnets pushing against each other. White pushes against white. Okay, so now Einstein was constrained by the fact that he was working with the Bohr model, trying to fit everything into that. It doesn't work. And nothing works because of Bohr and Einstein and all of them back then. They made assumptions that everybody had to fall in line with, and they just do not work. That's why they can't even predict gravity. They have no idea about gravity. This literally is what a proton is made of, is a ton of little particles. And that is why you can see these little particles separate as photons of light and then actually break into their muon and electron neutrinos, which are part of electrons. Two electrons together make a photon. A ton of electrons, 1,839 or so, right in that area, it's an uneven number, make a proton. And the uneven number means it wants one more to become a neutron. And if you took the exact atomic weights of an electron, which is 0.000585 atomic mass units, and you add that to the weight of one proton, which is 1 atomic mass units, you end up with the exact weight of a neutrino. So it's obviously just by taking one more electron, add it, now you got a neutron. The reason you have quantum is because you have an uneven number of electrons in the core. They want to attract more electrons because they're uneven. But the ones that are on the surrounding the black center, which is here, the black center, this is a crosscut. The ones that surround that black center say, no more white ones can get through here. We want to hold you away from us. And they keep them at a quantum distance. That's what quantum is all about. All right, this is a toy. It's called Attractor beam magnet. And it is really the whole basis of quantum. He's taking a dark core, which is going to be the positive, basically, dark matter, and he's putting a bunch of negatives around it which will repel any more negatives coming in. That is what a nucleus is. Now listen, I'm going to just shut off the sound and speak as he does this. So he's got a brass ring with 6 real powerful little magnets around it. Now, you see that? That is attracted to it. But if you turn it around, it pushes. So now what do we have? Right here, what we have right now is the dark center with the white core around it. Exactly what I'm talking about if you look at electron flood theory. You see, whoops. You see the dark core? That's that. You see the white stuff? That's those. The white ones want to push all the other white ones away. The dark one wants the white ones to come in. And it's so extremely attractive, that's gravity, that the white ones will come up and these ones will say, no, 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 you can't get any closer. And I'll say, well, what do you want me to do? He said, you stay right there. And I am going to show you exactly that occurring. Watch what happens. He's going to take another electron and try to get it close. Boom, there it is. That is quantum right there. The case is closed on quantum. This is a dipole. The electron is a dipole. Its white particle wants to get to the black particle in the center. So what is happening? The white side is facing in, but it's bumping against other white ones facing out. Because all the dark matter is in the center. So they push each other away and they pull each other in. There will be a distance between the two. And there it is right there. And it will stay right there. And he'll shake it around, it'll stay there. Now, if you started a fire or you heated the hell out of that, it would knock that electron away. And you would degrade that particular molecule or atom into something else. That's what combustion is. The molecule breaks down as the electrons get flooded away because of heat. Now don't forget, there's a huge field surrounding this thing, and it affects them way off to the sides. Now watch what he does. Excuse me. You see them? Look, they're being pushed and shoved away, way out on the edges. See them? This is setting up the quantum field. This is exactly what you would expect to see if you had a dipole nucleus, which we do. That's just the nature of the nucleus. It's a dipole. And then every other particle is a dipole. So they have push to shove. There's attraction but push. And because the dark core is so much more attractive, it wants to suck in every white particle that's around it. But they will only be allowed to get as close as the other white particles surrounding the dark core will allow. And that's why the bigger you get with the darkness in the center, that's all this means, is more darkness in the center. That means more things will collect around the outside. And those are called the valence electrons. Those are the electrons that surround a cloud, that surround this core. You've just seen it actually happen. Now, because electron flood theory proves, basically, it absolutely proves in my mind that everything is made of these tiny little electron particles, which an electron is not just a negative little pushy sparky thing. It is the black and white particle together, which is the dark matter and the electron neutrino, which is showers. Now, that means everything here is wrong. 100% wrong, because they say this, hydrogen, is only one of these. One of these and one tiny little bitty thing floating around, but it's not. It's 1,839 little bitty things and one more little bitty thing floating around, just as I have explained. So, as they get bigger and bigger and bigger and bigger and bigger and bigger, they have more and more and more surrounding electrons because they have a bigger and bigger and bigger dark core. Basically, that's how it's got to be interpreted from now on. However, there are periods, they call it periodicity. At a certain number of electrons, boom, they lock in. And then at a certain number, like here, it's only 1 for 1. But as you get bigger, helium is not just 2 protons. It's 2 protons and 2 neutrons. They had to throw the neutrons in because they couldn't account for this one only being 1 and this one being 2. It didn't work. It had to be 4. And as they go up, they add all kinds of extra particles in there to account for it. So this is totally wrong as well. So the periodic chart's wrong. Mendeleev has a little bit of an issue. I'm sorry about this, but this is just a fact. You want to get to reality, you've got to break a couple of eggs. All right, here's another thing I have to explain is the Schumann frequencies. They change, but 7.83 is the basic Schumann frequency right next to Earth, and that is the same frequency that our heartbeat runs at. I've always said that Earth is a biological creature, or was at one time, and the heartbeat of Earth is 7.83 and exactly the same as a human body heartbeat, Schumann resonance. We're going to go through all the things of electrical, physics, biology, anatomy, space. 100% has to change. It's totally changed now. Geology is completely, totally wrong because of mud fossils. Physics is totally wrong because the particles that make up the base particles are only these two little particles that I have shown you right here. And I can show all this stuff. I'm not guessing. There's no theory here. I do material science. That's what I do. All right, as I said, I have to explain every single interaction of energy. Sprites, elves, blue sprites, Brownian motion. I can explain all of this stuff. I have to explain heat and energy, bonding, molecular orbital transitions, superconductivity, all of that. I have to explain 100% of that, or else my theory does not work. And I can explain 100% of it. Brownian motion is nothing more than heat. Here's another one of Einstein's theory, special theory of relativity. It's completely wrong. It's totally wrong. I mean, it's just a thought exercise. It has nothing to do with reality. He's talking about time. You can alter time and space-time and warps and all that stuff. It's really kind of nonsense. Avogadro's number is just a bunch of molecules, how big of it is in a mole, they call it. Bose-Einstein condensate is the idea, I believe, of getting down to basically absolute zero. And all that means is no extra electrons in the mass. The mass has no extra electrons. Every one of them is accounted for. Yeah, here it is right here. He predicted that, and I agree with this, that at sufficiently low temperature, which means as low as you can get, and the only thing that just keeps lowering the temperature is extracting additional electrons that keep floating around. That's why things get hot and they get cold. If you take a cold thing and put it in a warm room, it'll come up to the warm temperature. It will get rid of all those extra particles, or it will suck up all those extra particles to make it warm as everything else in the room. If it comes in hot and everything else in the room is at 35 degrees and you're at 40 degrees with this other thing, it will drop by spending out the other things, and they'll go to 35.2 degrees, and your thing will go to 35.2 degrees. They'll all be the same ambient temperature. That's the way electrons move in and out. It's just a perfect flow. Now, at absolute zero, this Bose-Einstein condensate, you don't have any extra electrons. So what happens? It becomes superconducting. What does that mean? Give me every electron you can because I have none, I want them all. And it'll say, zip! They'll all go in there instantly, it'll superconduct, and then all of a sudden, it'll say, whoa, 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 I'm getting sort of filled up here. And it'll push back against them, and that's when superconductivity stops. And that's almost instantly because it will absorb every single electron you can give it. So you put electricity, zip! And then they say, whoop, I'm charging up. And that's what a capacitor does. It charges up until it gets full. And full means you're at the same temperature as everybody else. I have another video coming out today that's about temperature and what is it. So that's going to be another fun thing. All right, here's another one of Einstein's issues that is totally wrong. Theory of relativity. Einstein determined that the laws of physics hold constant for all non-accelerating observers. The speed of light is constant no matter how fast the observer travels. That's not true at all. He found that space and time were interwoven. That's just not true either. You cannot change time. Time is the time it is where you are. And if somebody else is somewhere else at that same time, that's what the time is there. It's the same as your time, only he's somewhere else from you. That's all it is. He found that space and time were interwoven and that events that occur at one time for one observer could occur at a different time for the next. No, that's not right. You're going to see it showing up at you because the light has to get to you before you can observe it. Yes, absolutely. That doesn't mean anything. It happened back when the time was that time. You're seeing it at this time. No difference in time. It's just that you see a car coming at you from a mile away. Well, you just see it a mile away. Then all of a sudden it arrives at you, and then you say, okay, that's a new space-time. No, it warped time? Hell no, it just came at you. It took time to get to you, that's all. Photoelectric effect is the most simple thing going, but they couldn't reconcile it because Maxwell's wave theory didn't predict that a particle could hit just a wave. A wave can't drive particles away. I showed you what the wave-particle duality is. It is a particle, and its magnetic field slams and pushes, and it hits hard enough, it will drive an electron away, just like I showed you with Latham's crazy tractor beam magnets. Wave-particle duality, I showed you how that works. So all of the things I showed you about Einstein are wrong. And I could show you them. I didn't just make them up like he did.